Hello students, I am Dr. Sanjeev Punia. In last lecture, we discussed about addition and subtraction, and we discussed that how we can design the circuit diagram as well as hardware implementation for addition and subtraction. And we discussed that these two are complementary to each other, so we can design addition and subtraction circuit in a single one by using the XOR gates. By using XOR gate, we can find that this operation we have to perform for the addition or for the subtraction. We saw the flowchart as well as hardware implementation for both. In today's lecture, we will discuss about multiplication in computer arithmetic, and we will see that how the multiplication process is going to perform inside the ALU. So let's start multiplication. As I told you earlier that there is no operation like subtraction, multiplication, division, etc. All the operations are based on addition. Suppose I have to multiply 2 with 2, 2 with 2. When I will multiply 2 with 2, then it will be 4. But it cannot happen in ALU. Inside ALU, it is going to add these two numbers. You can say, sir, addition and multiplication of both these two numbers are same, but this is not the case of each and every number. For an example, I am taking the example of 2 multiplied by 5. So this is 10. But when I am adding 2 with 2 with 5, sorry, with 5, then it is not 10. So this is by chance that in first case the addition is equals to subtraction. So this is not same. So what happens? Actually, as we know that the speed of processor is so fast that it works in fractions of seconds. So instead of multiplication, it performs the addition. 2 multiplied by 5 means we are doing 2 multiplied by 2 multiplied by 2 multiplied by 2 5 times. We are doing this. So if I add this 2 with 2, this is 4. I add two numbers. If I will add once more 2 in this, so this is 6. And if I will add one more 2 in this, then this is 8. And finally, if I will add one more 2 in this, then this is equals to 10, and that is equals to the multiplication of 2 into 5. From here you can see I add two numbers 5 times. This is 1, this is 2, 3, 4, 5. So I add 2 5 times. So this is equals to 10. Suppose again I want to find out the multiplication of 3 with 4, then this is 3 multiplied by 4 is 12. So what I can do, I can add a number 3 4 times. This is 1, 2, 3 and 4. This is a number 3 and I can add these numbers 4 times. So this is 3 plus 3 6 plus 3 9 plus 3 12. So these two numbers are same. So I hope now you have some idea that what is multiplication and how the process is going on to multiply two numbers inside ALU. So if I will summarize it, then it is a process, means multiplication is a process of successive shifting and adding operation. Means when we have to multiply two numbers, in this case, we have to perform addition and shifting of number again and again. As in our day-to-day life, we see that when we have to perform a multiplication, suppose I have to perform multiply 12 with 30, 12 with okay 1 3 with 2 1 2, then in that case 3 multiplied by 2 is 6, 3 multiplied by 1 is 3, and 3 multiplied by 2 is 6. Now if you will pay attention over, then we are going to write the first digit, that is 2 multiplied by 2, from here, not from the below of this number. Generally, either we write a 0 over here or we cross it, but we start from the first one. That is, we are shifting our partial multiplication one digit left every time. So this is the thing we saw in decimal numbers also. So multiplication is the operation of addition as well as shifting of bits. If we have two numbers, a number where the bits of first number is n and second number is m, then maximum possible number of bits required for that multiplication is n plus m. Suppose I have a number of 2 bit, I have a binary number of 2 bit and another binary number of 4 bit, and another binary number of 4 bit, then the maximum number of bits I can get, that is 8. Sorry, extremely sorry. That is 2 plus 4, that is 6. I will show you this by an example also. So suppose I have a number, a 2-bit number, that is okay, first I will write a 4-bit number, that is suppose 1 1 1 1 what what is happening? Okay, 1 and 1. This is a 4-bit number and I am going to multiply it with a 2-bit number. Then this number can be a 4-bit maximum number can be, this is 8 and 4, 12, 12 and 2, 14, this is equals to 15 and this is equals to 3. So when I will multiply 15 by 3, then it will be 45. So when I will write 45 in binary, then this will be 45 divided by 45. The process to write this in the binary, we saw that how we can change a decimal number into different binary numbers. So this is 2, that is 1, 2, sorry, 2 to the 4 and 2 to the 4, remainder is 1. Again, when we are going to divide it by 2, then this is 1 and 1, whereas remainder is 0. Again, when we are dividing it by 2, so this is 5 and remainder is 1. Remainder is 1. Again, when we are going to divide this number by 2, so there is 2 and the remainder is 1. Again, when we will divide it by 2, then this is 1 and this is 0. So if we have to write the binary equivalent of this, then we have to read the number like this, and this is 1 0 1 0 1 0. This is 1 0 1 1 0 1. This is the binary equivalent of 45, and you can see from here that it contains 1 2 3 4 5 6. It have 6 digits. So maximum number of digits require after multiplication of a number is n plus n, where n is the bit of first number and n is the number of bits of second number. It can happen sometimes that our multiplication result is more than the space or more than the bits we have. So in that case, there will be a overflow, as in the case over here, in case of 45, we saw that we require 6 bits. We require 6 bits. But suppose we do not have a register where the capacity of that register is to store 6 bits, then in that case, there will be a overflow, as we saw in case of addition and subtraction. So the multiplication rules for this is, as we know that in the case of decimal, we can multiply different numbers by different numbers using the tables. Here also, there is a rule to multiply each and every number. So when we have to multiply 0 with a 0, so 0 multiplied by 0 is 0, 1 multiplied by 1 0 is also a 0. 0 multiplied by 1 is also a 0. 1 multiplied by 1 is a 1. So we have to keep in the mind that when both the numbers are 1, we get a 1 after multiplication. Otherwise, in all the cases, the result of multiplication is 0. Or in another way, we can say that when any of the number is 0, then the result is 0. So this happen when we have to multiply two numbers. We discussed the rules of multiplications in earlier slide also, when we discuss the rules of addition and subtraction. When we have to perform the multiplication, as I told you, that this is the successive repetition of addition and shifting. So when we have to multiply with 1, it means we have to copy the content, same as it is, and then after adding, we have to shift. But in case of 0, there is no need to copy the content, only and only we have to shift that, because all the bits will be 0 at that time. And we will see these two different examples over here, that how we can perform that directly also. Now I will tell you the analogy of the binary multiplication with the decimal multiplication over here. As in the decimal number, we have multiplicand, multipliers, and final value. So suppose I want to multiply 13 by 11. So 13 is a multiplicand over here, and 11 is the multiply. These are the partial products, as when I will multiply 3 by 1, so this is 3, 3 multiplied by 1 is 3, 1 multiplied by 1 is also 1. So again, keep this in the mind, that the first bit, we are not using the first bit, we are taking the value of that first bit is 0. Or generally, if you will see in daily life, then we put a cross over here. Then suppose I am writing a 0 over here, then first bit of this number, first bit of this next multiplication, I am writing from the next bit. Means I am shifting this number left by 1 bit. So this is 1 multiplied by 3 is 3, and 1 multiplied by 1 is 1. So these are partial products, and to find out the product, to find out the final result, we have to add these numbers. So this is 3 plus 0 is 3, 1 plus 3 is 4, and 1 plus this is 1 only 1, so this is 143. This is the way that we follow in decimal multiplication. This is the same case we have to follow by using the binary multiplication rule. As there is a number 1011, if you will see that I I take the numbers in such a way so that it will be easy to understand. I took a number, this is 1101. This is 8 plus 2, 10, and this is 11. So this is 11 and this is 101, that is 5. So we have to multiply 11 with 5 if we want to find out it using the decimal. Then 11 5 is 55, means our result should be 55 in the binary. So let's try to do it, that how the things are happening in case of binary numbers. So this is what is happening. This is okay. Yes, now it's fine. So now we will try to implement this in case of binary. So according to the rule as we studied, first we will multiply this 1 with all these bits. So 1 is going to multiply with 1, so this is 1, and 1 is going to multiply it by 1, so this is 1. When 1 is going to multiply by 0, so this is 0, and this is 1 multiplied by 1 is 1. So you can see over here that I multiplied this number multiplicand by 1, then I get the same number. As I told you in the last case, that when we have to multiply by 1, then in that case the multiplicand will be same, or in the partial product we get the same number, and after that we have to shift. And in case of 0 we have to shift only. So next you can see that when we are going to multiply with 0, then after multiplying with 1 we have to shift it in the left 1 bit. So we shift as we perform multiplication in the decimal number. So we did that. 0 multiplied by all will be 0. Now again 1 is going to multiply, we have to shift it. We shift 1 bit in the left, and when we multiply by 1 we get the same number, that is 1011. Now when as as per the decimal numbers multiplication, over here also we are doing the same thing to get the final product or final result. As we are adding over here, we will add here also. So this is 1, this is 0, this is 0, so this is 1. This is 1 plus 0, this is 1. 0 plus 0 plus 1 is 1. This is 1 plus 1 is 0 with the carry 1. So carry is 1 over here. So this is 1 plus 0 plus 0 is 1, and this is 1. So you can see from here that the multiplication in binary is look like the multiplication in decimal, but the difference is that multiplication is going to be performed as an addition by the ALU, that is arithmetic logic unit. So this was the concept I want to tell to you, that how it is similar to decimal numbers. So here we saw the rules that how we can do that, and we saw the one example in decimal as well as in binary also. Now we will see One more advanced example, this multiplication we have to follow using different multiplication algo. I will tell you that algo after this lecture, means in the next lecture suppose. But what is happening over here? The thing is that we are multiplying 1, 2, 3 and 4. There should be 4 rows. When we have 4 bit, then there should be 4 rows. But there is not 4 row, there is only 3 row. If you will see anywhere, then how many digits we have? How many digits we have? Here we have 2 digits, so we get 2 rows. Here we have 3 digits, we get 3 rows. So number of rows are equals to number of digits, but here number of rows are less than number of digits. What I did in this, to save the calculations, to save the time, I know that when I am going to multiply a number by 0, then I get 0. So I use the concept that when I get a 0, then I shift two numbers in the left. I shift two numbers in the left. You can see that in this 1 multiplied by 1 means same number, and I am leaving this. I am leaving this means shifting this. Again 1 is going to multiply, so this is also same. Now I should shift this. I should shift this means I should left these two digits. But when I have a 0 over here, so I shift one more. I shift one more. Instead of doing multiplication of 0 with all the numbers, and after that shifting I save some time. And when I am multiplying with this number, then I get this, and after the addition I get this number. So this happens in both multiplication that we will study later. So this was the basic concept behind the multiplication inside ALU. Now here we will discuss that how the hardware can be implemented for a multiplication in arithmetic logic unit. See, we have two numbers. We have two numbers, multiplier and multiplicand. Multiplier and multiplicand, and as I told you that we have to perform two operations. First, one operation is add and second operation is shift. In both the numbers, in multiplicand, mn minus 1 is the sign bit, and in another number multiplier, here also qn minus 1 is the sign bit. When we are, this is shift and logic unit, shift and logic unit. When we are multiplying, you can see that we are using a adder over here. Means one number is coming from this side, second number is coming from this side, and we are adding these two numbers over here. And then we are transferring this number to accumulator. Then to shift it, we are going to shift it right, so that we will came to know that how many times we have to shift it, and it is calculated by a counter, and the value of counter is equals to number of bits in the number that we have to multiply. So this was the basic concept of implementation of the hardware. Now we will see the flow chart of this and it will be more clear. See, over here we have two numbers. Suppose I have a number b in multiplicand and q in multiplier, as we discussed in the last slide, that we have two numbers m in the multiplicand and q in the multipliers. So we have two numbers. One number is in the B, multiplicand is in the B, and multiplier is in the Q. This QS, QS is the multiplier sign. This QS contains the multiplier sign. The BS contains the multiplicand sign. This BS contains the multiplicand sign. So by using this BS and QS, we will able to find out that the result will be positive or negative, or we will get this is, as this is a XOR gate, and value of this XOR is 1 when both the numbers are different. Both the numbers means when B, the sign of B, that is multiplicand, and the sign of Q, that is multiplier, are different. In that case we will get a 1 over here, otherwise we will get a 0. As I told you that the counting is depend on the counter. This is sequence counter, that how many times we have to multiply. So that record is kept by the sequential counter, and this is equals to n, where n is the number of bits. N is the number of bits that we have to multiply. So initially we kept accumulator 0, and this E is also 0. This E is also 0. That Qn, Qn is the XOR between multiplicand and multiplier. If we get same number, means if these both are positive or both are negative, means they are same or they are different. When both the when sign of both the number is same, in that case we will get a 0, and when sign of both the number is different, then we will get a 1. The main thing is in this is, as we discussed, that we have to check that the circuit is going to perform as a adder or a subtractor. Only and only this is the difference over here, to check the value of Q. If this is equals to 1, then it will perform as an adder, a plus b. If this is equals to 0, in that case it will perform as an subtractor, and you can see from here that this is EAQ and SC is SC minus 1. And over here we are adding the both the numbers. In last we have to check that sequence counter is equals to 0 or not, means we have to multiply again any bit or not. If there is any other bit left in the multiplier, then we have to follow these steps again. as we are going to multiply one bit, then we are going to decrease a number in sequence counter. So suppose initially I have 4-bit number, then suppose I have 10101 and I want to multiply it with 101. Then in that case, sequence counter contains n equals to 3. N equals to 3. So when I will multiply this 1 with all digits, then SC sequence counter will decrease by 1. So it means this is 3 minus 2, that is 3 minus 1, that is 2, means I have to multiply 2 more times, and when it will multiply with 0 also, means this is 2 minus 1, it means we have to multiply only once more, and when it is multiplied with 1, then 1 minus 1, that is 0, means there is no other number to whom we have to multiply, and the we get the final product, that is result of multiplication, and result will be in EAQ. In EAQ. Here in EAQ, this contains the sign bit. This contains the sign bit of the final result, whereas it contains the magnitude of the result. So in this we discuss all the concept behind the multiplication, and we saw that how these things makes effect when the things are going to be changed in case of zeros and ones, and how we can escape one row or one bit multiplication when the bit is 0. So today in this lecture we discuss about the multiplication, that if there are two numbers of n bit and we have to multiply that, then maximum number of bits required are 2n, and if we do not have sufficient space to store the product to the result, then there will be a overflow. Then we discussed that if both the numbers are 1, then the multiplication of that is 1, otherwise multiplication is 0. When the multiplier is 1, then in that case we have to copy the same number and have to implement a shift after that. In case of 0, we have to perform only a shift operation. Then we discuss the analogy between the decimal and binary multiplication. In the last, we discussed that how we can design the hardware of a multiplication, and finally we discuss about the flowchart of multiplication. In next lecture, we will continue arithmetic arithmetic logic unit, the and in this we will discuss the operation, division operation. So we will discuss about the division in arithmetic logic unit or computer arithmetics in next class. I hope it will be clear to you. Thank you.